New from ESCO Institute. This is what people are saying about the ESCO EPA Section 608 online interactive course.
Great presentation and understanding of materials. The clarity of topics are consistent, which helps the learning process immensely.
The flashcards, along with the excellent graphics and clear instructions, are fantastic.
I took the 608 core test before I came here and got 45%. After taking the ESCO course, I passed with 85%.
Do you need to get 608 certified? You will find the ESCO EPA Section 608 interactive course on the HVACR Learning Network. The HVACR industry's leading source of online and digital content. Visit us at hvacr.elearn.network.
Thank you everyone so much for joining us on Did You Know, the ESCO HVAC show. We're so grateful that you're with us today. Hopefully our audio is coming through properly now. The computer did a little crazy intro thing. So a couple weeks ago, we actually did a show on air quality corrective devices. And there was a lot of controversy in the industry. I actually personally was really... boy, how would I say that? I was confronted very significantly about the topic at hand. And, you know, we always say, oh, thanks, Osvaldo. Appreciate you joining us. Osvaldo is actually joining us from Belize. So, yeah, it's wonderful to have our international technicians and industry members joining us today. Thank you for joining us, Murph. Everyone out there in the audience, let us know where you're joining in from. Thanks, Howard. Yeah, I'm going to figure out, hopefully when I get into our new studio, which is right around the corner, boy, I've got some exciting things to share later about that. So when we start talking about technologies and innovations, it's always important that we bring to you the technical presence of every product. We bring you firsthand education. And today we're fortunate to have Professor Yogi Goswami. How are you, sir?
I'm doing fine. It's a pleasure to be here.
You know, it's an honor to have met you. You know, we just started talking a couple of weeks ago when we started having this discussion about bringing your product and your technology, your innovation onto the show to bring to our audience. And the more I get to know you, the more I am absolutely intrigued and just blessed to have you on our show. So I think we should set the presence of who you are within our industry, and to really show our industry the level of ingenuity that is going into this technology. So, Dr. Goswami, co-founder, as well as with Lovely Goswami of Applied Photonics. You are a distinguished professor at the University of South Florida, 43 patents, National Academy of Inventors, the Florida Inventors Hall of Fame. You've had 23 books, 400 technical papers, editor-in-chief of Solar Energy Journal, editor-in-chief Solar Compass, and a life fellow of ASHRAE. And I think it's very important that people understand that when we approach these topics, we're not bringing them to you from a sales perspective. We encourage you to check out the product. The most important is we're bringing the technology to you so that you can understand what it is, so that you can make your own decisions. And so if I sounded salesy a couple of weeks ago, I truly apologize. I was trying to give my own personal experience on a product. So today we're going to dive into a technology that I knew nothing about a few weeks ago. And would you mind introducing us a little bit about your company, and then we'll get into the technology and products?
Yes, indeed. So let me start with this brief presentation.
Yes.
As you know, I don't have to tell that indoor air quality is a growing crisis
Everywhere.
all over the world.
Yes.
It's not just the allergens. It's not just the viruses, bacteria, mold spores, volatile organic chemicals. All of these cause respiratory issues infections, and in hospitals, hospital acquired infections. So this company, our company, is introducing the most advanced air purification technology for the central air conditioning systems, and we call it the ViroZap. And you will understand why we call it ViroZap just a little later.
Okay.
It's a plasmonic photonic technology. Most people, even physicists, haven't even read about it.
Yeah.
It is that advanced. It's because I have been doing research in these areas for a long time.
Right.
Uh, the we have introduced 3 products on the market, and these are for all kinds of residential and commercial buildings, institutional buildings. They are UL certified, and for central air conditioning systems, the only products cleared by FDA 510K.
Wow.
And they meet ASHRAE standard 241 and 170. 170 is for the hospitals,
Sure.
241 is for the other areas. And so let me go to the next slide here.
Yeah, because even here in Indiana, we're starting to see changes. One of the things that we witnessed a lot this year was wildfires in Canada that was actually bringing significant amounts of smoke here in Indiana, and so that is
Yes.
something we've experienced, but not to the level that it was this year. And so there were times it was very difficult to even breathe comfortably outside.
Yeah, and it's not that the wildfire has to be in your area. If
Yeah,
it's in Canada, you will still get that air that you don't want to breathe. And
absolutely.
wildfires are happening all over the world, partly or mainly due to climate change. But here's the other part that most people don't know: there are new viruses coming out because of climate change. Hmm?
Absolutely.
And so these viruses are on the horizons, and more than 5 million people already die yearly due to indoor air pollution.
Yeah.
And that is on the rise all over the world. So, and the other part is that the conventional solutions that are available on the market, they are not adequate. Some would take care of one part of the problem, not the other part. And in some cases, they actually can bring additional problems
Mm.
into the picture. And so the WHO Director for Public Health, she said, few risks have greater impact on global health today than air pollution. The evidence signals the need for concerted action to clean up the air we all breathe.
Wow.
So that is what motivated me to invent these new technologies, and this is the most advanced technology that I have invented.
It really brings up a lot of topics of conversation since COVID. A lot of people started looking at the quality of air and viruses, particularly after that period. And I know for myself here recently, since about February, I've had 3 bouts of bronchitis this year. So I had a very long spell of just having congestion and things that were not going away with typical antibiotic treatment. So I went to a specialist here just a few weeks ago, about 3 weeks ago. And as we're going through all the tests, he comes back and he says, "Well, let me let me guess. This probably started. You must have had COVID around first of the year." And I was like, "Yeah, I actually did." He says, "One of the things that we're finding is antibiotic resistant viruses that are now starting to become more common than we've ever seen in the past, and they're viruses that, in many times, we've never even been introduced to. And so we're starting to see changes in viruses and bacteria that we've known in the past and that are actually taking new forms. And so we're going to put you on a completely different treatment and we're going to see what that does." And it really was a significant difference. But it really makes us think about the air that we breathe and new contaminants that we're starting to encounter. Very cool.
Yes, indeed. Not just the viruses that we've known about, but their
Mhm.
mutations are
Yes.
coming on the horizon, and some viruses that are totally new because of climate change, where we don't have any immunity. to
Right.
those. So we are confronted with all of these, and the current solutions are, filters, HEPA filter being the best among them, maybe germicidal lamps, or carbon filters, or other adsorption filters, or air ionization. The point is that all of these would take care of maybe one part of the problem or the other part of the problem, but not all of them. In
Okay.
some cases, I don't want to go into the details, but in some cases, they cause additional problems that we should be worried about.
Yeah, that was one of the concerns with the audience from a few weeks ago, is that yes, we can use some types of technology to treat one item, but sometimes we have byproducts of that.
Yes.
And so when we start looking at treatment, it's important for us to approach this from an educational perspective, to understand, why we're moving into a technology that's more advanced than we've had in the past. It's because we're now looking at providing multiple layers of protection.
Indeed. And in some cases, these byproducts that are not good for us, we figure out and we get worried. Some cases, like germicidal lamps, would produce ozone.
Right.
We may be breathing that and not even know about it, but over long periods of times, it causes cancer inside our bodies. And then we can't figure out what caused the cancer. We try to say, oh, maybe genetic, maybe something else, but it could be what we are using for air conditioning system.
Okay. Interesting.
So going to our solution, which
Mhm.
is the most important part here, is a patented plasmonic photonic technology that destroys viruses, bacteria, mold, and other spores, as well as volatile organic chemicals.
Hmm.
And
Okay.
maybe we'll come later to the point when I say destroys.
Okay.
In some cases, these technologies, they say, oh, they kill viruses and bacteria. We don't want to just kill, we want to destroy them completely.
Yeah, because like
So
with a virus, isn't there the potential, if a virus is not completely destroyed, say its cellular membrane is broken, it does still have the potential for reproducing. Is that correct?
yes, indeed. So there are other problems also. For example, when a bacteria or a virus is killed, its skin peels, and
Huh.
under the skin they have endotoxins.
Okay.
And so while they were living, those endotoxins were protecting them. Mm. But when they die and the skin peels, they get into the air,
They're
and
released.
some people have more lethal allergies to those endotoxins than they had to the original bioaerosol.
Very
So
intriguing.
that's why it's important to destroy them where nothing is left.
Hmm. I'm so thankful to have you with us.
Well, it's a pleasure. I'm a teacher,
Yes.
professor, so I want to teach these things.
Absolutely. And many a times in our industry, we have fantastic resources on the technology side, on the equipment, on the operational, on the design. But when we start getting into air, it's a more sensitive topic, and there's a lot of misinformation in the industry. And
Mhm.
so that is a reason I was very excited to have you with us.
Yeah, and actually, on the right hand side of this slide, you see two pictures, and the top picture is a spore. Spore is like a seed form
Right.
of a fungal organism. And this one is Bacillus subtilis, which is a close cousin of anthrax.
Hmm.
And so this is when it's live at the top. And when our technology starts working on it, you see what's happening. It's like it's evaporating. So it's being changed to just carbon dioxide and water.
Wow.
Nothing else is left. So that's the important part. And so we just use low grade UVA light and a nano coated medical grade filter, and then integrate that into the central air conditioning system. That's all that's required. And it not only takes care of the viruses, bacteria, and spores, but also volatile organic chemicals, which can come from wildfires,
Right.
and come from actually a lot of the things we use indoors,
A
like
lot of our manufactured products, yes.
yeah, all the manufactured products, carpets, paints, and so all of these, but it will destroy all of them.
Yeah.
And it's does not produce any harmful byproducts.
Very
That's the important
intriguing.
part. Okay.
Kendrick, thank you for joining us in Chicago. Very interesting, isn't it? And as we're going along, we'd really appreciate if you have some comments, you have some questions along the way, throw them in the chat. We would love to dive a little deeper and help you understand the technology better.
Yeah, certainly. Now, what we're showing here is because our technology is cleared by FDA, and that's the most stringent uh, type of criteria they use
Sure.
to clear any technology. They asked us to send it to a lab that they trusted, and that lab tested for two kinds of viruses. One is an RNA virus, the other a DNA virus, MS2 and FIAX. Guess what? All the viruses are either RNA or DNA. So if it destroys these two, it destroys all viruses, any virus,
Wow.
whether we know of them now or not. And so here the destruction is, you normally hear 95%, 98%, 99%. No, this is 99.999%. That is like sterilization,
Yeah.
or 99.9995%. And then they tested against two types of bacteria. One is a gram positive bacteria, the other is a gram negative bacteria. And guess what? All bacteria are either gram positive or gram negative. So if it destroys these two, it can destroy all bacteria. And again, it's not 95% or 97%, it's 99.99993%. And the other one is 99.9997%. That means really there's nothing left there.
Wow.
And that's why FDA considers 99.99% as complete disinfection. This is going way beyond that.
Even beyond.
And so then they tested against two types of mold and fungal spores. One, a black mold, which is very prevalent in USA, in hot and humid
Especially,
areas.
you bet.
And the problem with these is, once it starts growing someplace, you can't get rid of it. And so it can, you make conditions inhospitable for it. It can live in seed form for millions of years if it has to. But what we are doing is we're destroying completely. 99.9939% is the black mold, and Bacillus subtilis, which is close cousin of anthrax. Anthrax is Bacillus anthracis. And so it destroys 99.9961%. So the point is that it destroys all kinds of viruses, bacteria, and mold and other fungal spores. Now, when it comes to volatile organic chemicals, the test was done against the toughest organic chemical, not the ones that we get. They are easier to destroy, but toluene is a ring compound. And when
Structural.
yeah, so when you pump gasoline, you might breathe toluene there, benzene, toluene, ethyl benzene, xylene. And so we tested against toluene, and as you see, going from close to 1,000 ppb is just going straight to zero. And that's in a very large room, which is the environmental testing chamber.
So within an hour, we're
Yeah,
significantly reduced.
Right. And so, as for the products, we have applied this technology to 3 different products that cover all kinds of buildings that we can come across. One is the ViroZap Flex, which is the top one,
Okay.
and that goes into a duct of maybe residential system, a
Sure.
small commercial system. And I'll show you pictures of those also where
Okay.
they are actually installed. The other is ViroZap Mega, which is this one at the bottom left. And that goes into large commercial buildings where you have a bank of filters.
Oh, yeah.
A-
Large
And,
air handler.
and,
Hmm.
and this one just seamlessly replaces those filters. You take those filters out, push this unit in, and that's all you need to do. Then the third one is ViroZap Nano, which is a modular type of unit. In fact, it's behind me also, where there's just a light bank and a filter bank. Hmm?
Okay.
And so it's modular, so you can put the light unit and then you put the filter unit over there.
Okay.
And again, I'll show you a picture of actual installation.
Yeah, absolutely. You know,
Okay.
I know one of the questions that I'm surprised hasn't popped up yet is anytime we talk about new filter technologies,
Mhm.
we start looking at, what type of pressure drops or restrictions do we have across the filters?
That's an excellent question if somebody has it, and I'm glad you asked. Now, in our case, we tell what MERV rating our system is applied on, or we go with the customer's requirement of MERV rating,
Okay.
whether it's MERV 15, MERV 13, even HEPA. Hmm? And so the pressure drop would be what you have, and that is all available even online. How much is the pressure drop on MERV 13, MERV 15, MERV 16, or MERV 11? Hmm? And so our catalytic system can go on any of them.
Wow, fantastic.
Yeah. So so now I mentioned the ViroZap Mega,
Yes.
that you see on the left hand side. Right hand side is a sort of a picture of how filters are on this bank of filters in large buildings.
You bet. Especially
Eh,
hospitals and,
Right,
we're
right.
using large makeup air. Yeah,
Hmm. Yeah.
absolutely.
So all you do is in those cases remove those filters, push this unit in there, and it comes in a way that you can pull this. You see this handle, so you pull it out and you replace the filters when you have to replace them. Very easy to change.
Excellent.
So then so this one shows a building with these existing filters. I just put that in there, so you can move these filters out, push our units in. That was at a library building at
Sure.
the University of South Florida.
Okay. Yeah,
Yeah,
absolutely. Seen many of them in our commercial and industrial facilities.
right, right.
Yeah.
Okay, so this is a picture of, I mentioned this ViroZap Nano, hmm, the modular one. So this is a research laboratory building at the University of South Florida, and they had MERV 15 12-inch wide filters. We removed them and put the light banks, and our MERV 15, they're not 12 inches, 2-inch, but we provide enough surface area with the number of pleats that the pressure drop is the same as that.
That MERV rated original filter.
Yes, yes, indeed.
Okay.
And
Very
so,
nice.
so you can see that it's a very nice installation
Yeah.
and just works beautifully.
I'm liking this.
Okay. So now, so this I mentioned ViroZap Flex. So you see two of those units in a duct. In this case, it was put in a research lab. Uh, so all they did was cut the duct and put transition pieces.
You bet.
And these two units are there because it's a large lab, so they put two units in there.
Okay.
Okay. So, uh, what are the places where you can use? Of course, hospitals is a big application.
Yeah, I would think that would be some of the largest demand.
I think so. I mean, hospitals all over are failing the hospital-acquired infections
Sure.
criteria. Mm.
Yeah, we're
And
seeing
so,
things like MRSA, and, things that are really causing, significant symptoms with patients that didn't come in with them, which
yeah.
is scary.
But if they have our system in there, they will be passing that criteria.
Wow.
Schools and colleges. You know that kids get sick when they go to schools. They come home and then parents get sick. I mean,
Yep.
all parents know that very well.
Absolutely.
Okay,
Yeah, first week of school, you're just waiting to see what adults are getting sick next.
right, right. And so that would be where you would want to put these systems.
Hmm.
All of us are worried when we go to the airports or malls or other commercial areas. And so all of those should be having these kinds of systems.
Yeah.
And then, of course, buildings, residentials. I mean, that's where, because people make their own decisions, people want these systems now. Mm.
Hmm.
We get those calls every day.
I'm sure. I just had a conversation and an experience on Monday, so I flew out to New York to be a part of the opening of Climate Week at the NASDAQ in New York, Times Square.
Mhm.
And I was having a conversation about air quality in flights, and I had never spent much time looking at the air conditioning, the HVAC system on an airplane. And as we started diving into the mechanics of it, it was apparent that they're starting to have concerns with the actual pumps, right? They have a seal and a shaft. And if you've ever been on an airplane and you've noticed the smell of fuel,
Mhm.
you
Right.
actually are. That's
Yes.
fumes that have bypassed the pump
Mhm.
and has actually introduced it into the airways. And
Yeah.
so we think about those VOCs, those pollutants that are even being introduced into our air in those, sealed on those sealed
Yes.
passenger flights. And then we think, man, are there ways that we could improve the filtering of air on airplanes? And
Yes, indeed.
I
Now,
prime
if
candidate.
our system is there, it would just completely destroy those fumes. And they don't have any choice right now,
Yeah.
because the way the system, the burners and that system works, that some of that fuel gets mixed into the air that's getting into the cabin.
Yeah.
And that's what you smell when the plane is on the tarmac sitting over there
Yep.
before it takes off. And after it takes off, that those fumes are still there,
Hmm.
because you don't replace 100% of the air in
Right.
there. And and then there are people, some are sick, some have viruses, and in travel, uh, most people get sick. And so I wish that the airline industry notices this. This will take care of their problems.
Very intriguing.
Hmm. Okay. So all right, so I don't need to go through that. uh, uh, this technology is well protected with all of the IP. Hmm? And then you have our backgrounds. I do want to mention that you gave my background. Lovely is she's a scientist, master's in chemistry and biochemistry, but she's a serial entrepreneur. This is the third company that first two, advanced technologies and testing labs, she exited that company in a nice way. And then the next one, Molecule, which is still exists, but she was the founder of that company. And but they sell only portable products, portable air cleaning products, not the ones that we are marketing, which integrate into the central air conditioning
Yeah.
system.
Yeah, absolutely.
So we are on a global mission to make all buildings safe and stress-free environment to work and to live, and keep people safe for future and pandemic. And just as a background, if you would let me say that,
Yes.
why did I develop these technologies?
Right.
Because you mentioned I was editor in chief of the most prestigious solar energy journal, or Solar Compass journal, and the books are on energy conversion, so on. It's because my son is asthmatic from birth,
Okay.
and so we took care of his food allergies. But then I figured that there were some triggers in the air that he was breathing. And I was not about to invent a technology. I went to an ASHRAE conference to listen to the experts. And the more I listened to them, that more I felt that they did not even understand the problem. How would they give us the solution? On the way back, I thought of a solar technology I had developed to clean up contaminated groundwater at an Air Force base, that we could use that. But for indoor air, we won't use the sun, we'll use light of the wavelength
Right.
that is necessary, and we would apply that catalyst on a filter. And so that was the invention that started. And then that was the first generation invention. Then the second generation invention, which was photoelectrochemical oxidation, that went into a product called Molecule. And this is the final one, which is the most advanced plasmonic photonic technology that destroys all viruses, bacteria, mold spores, and other spores. So you don't have to worry about what happens in a future pandemic,
Hmm.
because you will be protected.
Wow. That is a lot of information. Anyone in our guest have any questions along the way? Because I'm sure, with a new product, new technology, there's bound to be some curiosity. I am myself along the way. I'm thinking, okay, it can kill viruses and bacteria. It's going to kill me.
So here's the thing, that the light we use is
Yes,
LED lamps, and it is what we are exposed to when we go outside in the sunlight.
sure.
Nothing more than that. Hmm?
Right.
And so we don't need to worry about that. We don't produce anything that is hazardous. Our final products are from all the bacteria, viruses, and VOCs, just carbon dioxide and water. And so sometimes somebody says, oh, does that increase the amount of carbon dioxide? You can't even measure it, because
Right.
if you measure the total mass of viruses and bacteria, it's so tiny, and that's the carbon inside there that's becoming carbon dioxide.
Okay. Osvaldo had a very interesting question,
Okay.
and I had really not thought about this. How does it respond to carbon monoxide? Say if we did have a carbon monoxide leak from a failed heat exchanger in a gas appliance, is there any type of chemical reaction with that as well?
Yeah, this is an oxidation technology.
Okay.
So as long as we are oxidizing carbon monoxide to carbon dioxide,
Yeah.
we could do it.
Okay.
Uh,
Yeah.
or what we can do, in another process, they try to change carbon dioxide to carbon monoxide.
Yeah.
No, we can't do that. Our
Absolutely.
technology will not do it.
Yeah, it's very intriguing though. So, in that process, with the human contact, if I have some skin cells floating through the air, that's probably going to be the thing that would come into contact with the filter medium and the
Yeah,
reaction.
right. So there are certain things like dust mites. Hmm?
Yes.
Okay. So this technology will destroy dust mites.
Okay. Wow. Love it. So, how long have you been working on this technology? I mean, it seems like it's a lot of research and a lot of products along the way.
Indeed. So I started looking into it in 1993,
Hmm.
because I normally go to conferences where I'm the keynote speaker or the plenary speaker.
Sure.
But I went to that ASHRAE conference to listen to other experts.
You bet.
But they did not really have the solution.
Sure.
So I started working on that at that time, and a number of students have done masters and PhD in the research. So the technology we developed, it worked, and so we commercialized it. But then I figured that there is some improvement I can make. So that was the next generation technology, photoelectrochemical oxidation technology.
Mm-hmm.
And that then went into the next product called Molecule. And then I was working on another cooling technology, plasmonic radiative technology, and I figured I could apply that here also. And so added that, and it improved the performance by 50% over what we put in molecule technology. And so overall, to answer your question, it's been since 93, and a number of my publications are in this technology. They peer reviewed, and the reviewer said yes, that this is great.
Very interesting. Yeah, that actually kind of comes into one of the questions that Brian had, was asking what third-party validators, because I know like through that process, especially with the FDA, that they're going to have third-party validators along the way.
Right. So in our case, for the FDA certification, they are the ones who said, here's a lab that we trust.
Sure.
You send your samples to them, your filters to them. So we sent the whole system, not just the filters.
Right.
And so they tested, they sent the reports to FDA as well as to us. And so that validation, you know, and what you saw was not just 99.99%, which FDA would say is complete disinfection, but 99.99993% or 9995%. And other than that, it's the wherever we have installed the systems, the results are over there, and people over there say that they are very happy with this.
Osvaldo, you got him very intrigued. He's asking of it, have you considered it for automotive filtration?
I hope that we can convince auto companies to do that. Because in auto companies, whichever companies boast that they have the best filtration system, all they're doing is putting a HEPA filter.
Right.
And you know what? The gases that you're worried about, exhaust from other cars, well, HEPA filters can't filter out gases. Gases pass through. They filter out particles that are 0.25 micron or above, but not the gases. Gases are molecules. And so I hope that the auto companies will say that, yes, we want this technology. And I'm hoping that one of the high-end companies will probably do that. But we would like to have this in every car. Because one thing that worries me always is when I'm in a car, as to what I'm breathing. All my car is doing is filtering the air that's coming from outside, but it can't filter out the exhaust gases.
Yeah, absolutely. Where can we learn more about your products and the validations for the
All
products
right.
themselves?
So the website, I believe it was on that last slide of the presentation, but it's Photonics, Photonics, aphotonics.com. So if you type that aphotonics.com, you will get to that website. It's www.aphotonics.com, and it has a lot of information, including reports and other information. Oh, okay. So you got to it.
Sure. Yeah, absolutely. It's a
Okay.
fantastic website.
Yeah. Thank you.
Yep. One of the questions that just came in was, do one of the units apply for a 1-inch filter for, say, a residential application?
So even for residential applications, we have 2-inch catalytic filters.
Okay.
And our units are designed that you can fit into or above the air handler in residential systems very easily.
Sure. Absolutely. And you actually have some of the products with you today.
Yes, if you look behind me, uh, so we have the Mega. hmm,
Oh, let me get
ViroZap
this up
Mega.
here.
We have the ViroZap Flex, and this is part of the ViroZap Nano, or the modular unit.
Very nice. All right. Anyone else have any questions for us for today? So what is the next evolution? It seems like you're on a constant quest for new innovations and technologies.
Yeah, I think this technology is the most advanced. The reason I'm saying is that it has all of what we had in the previous 2 generations,
Mm-hmm.
but we added a plasmonic, which is like these nanoparticles that radiate at a certain frequency,
Mm-hmm.
which matches the light
Okay.
frequency that's incident on it, and that improves the performance quite a bit.
That is intriguing.
Yeah. So other people will hear about such developments. It'll take a long time for them to figure out, but
Right.
we have it in the product.
Love it. All right. Well, that's a lot of great information. We really appreciate it, and I encourage everyone to go over to aphotonics.com, learn a little bit more about the products and the technologies, and Dr. Goswami himself. I'm telling you, he's a very intriguing person. It's worth your research time.
Thank you.
Well, Dr. Goswami, thank you so much for joining us. We appreciate everybody hanging out with us today. We're going to wrap it up a little bit early, unless anyone has any other questions. We're thankful for you all joining us and hanging out with us, and we'll I'll tell you where we're at with the mobile studio. So I'll get some photos tomorrow. I am just about worn out. I've been over there as much as I can every day, diving into it. So the podcast studio is done. The video production is like 90% done. And I will be wrapping things up with that tomorrow. And on Sunday, headed up to Northern Indiana. And we are actually going to do a complete solar installation on this, Dr. Goswami.
Okay.
We're very much advocates about clean energy in any form that we can. So we're going to be doing having a solar company, Solar Energy Systems is going to be doing 2,500 watts of panels. We're going to be doing 6,000 watts of inverter, and we're going to be doing about 800 amp hours of battery storage. So it's going to be quite the interesting. Yeah. Thank you for joining us so much today, Rashana.
Yeah. Well, it's a pleasure for me, and I hope the audience enjoys and they get new information. They're welcome to go to the website and then contact the company if they need.
Awesome. Well, thank you so much for joining us, and we will see you all again next week on Did You Know, the ESCO HVAC show. Bye, everybody.